Well, hi, and welcome to my shop. So I'm about to start on another radio here, a fantastic looking radio still in its bubble wrap. So this makes me very nervous, in fact, because I actually like working on radios that are a mess, that are pretty close to going in the garbage, and then I can restore them without much concern about damaging the radio. This one, wow, okay, let's get the bubble wrap off it. There we go. $100. Okay. There we are. A little bit of dust on it there. Beautiful shape. Just lovely. Okay. Very nervous now. Okay, let's get rid of the bubble wrap. So the owner of this radio and a couple more that I have to work on, I have 3 radios from one individual here to do some work on. I think what he told me, if I got it straight, is I hope I got it straight, too nervous to plug them in to even see if they work. I may be wrong in that, but I believe that's what he told me. So, Nordmende radio. Can't read this. So there was a tape or something over top of this, probably blocking it from view, I'm guessing. This is all in German. It certainly suggests that this radio was purchased in Europe and brought over to Canada, as opposed to being built in Europe and then sold in the United States or Canada. So, German, yes. Okay, so here's the TA, which I think is a tape input. I'm not absolutely sure. There's the folded dipole antenna input for FM radio here. This has got the antenna here and a little ground symbol there. So this is the shortwave antenna, and I can see there's a bar or a rod antenna just behind there. I can see it. Here's an external speaker. This is describing the, what is this saying? UKW dipole und Hochantenne. Is it talking about this in some way? UKW dipole. Yeah. So I don't speak German, so I don't know what that's telling me. Okay, let's look again at the front. In fact, let's look at underneath it. Sometimes there's a little surprise. I wouldn't say there's a surprise there. So, looks like an aluminum strip on cardboard. A lot of these radios were made so you don't have to take the radio out of the cabinet to work underneath the chassis. I don't know about this one. Off button. A lot of these radios, the on-off button doesn't work. This radio's off at the moment. It's not plugged in. I haven't plugged it in yet. I'm just playing around. Yeah, it sounds good. Hard buttons to push. This has got to be volume. Does it say what it is? It does not. The outside one appears to be a fake. Doesn't seem to want to turn anywhere. It's just an inside one here. This has got to be tuning, wouldn't it? Where's the pointer? Hey, where's the pointer? There it is, right there. Okay, so there's a pointer here. You can barely see it. If I turn the big wheel, you see the FM. That's the FM band. The pointer moving. The other dial should do this pointer. It's going nowhere. It feels like I'm tugging on a string. So I think it's probably in fact what I'm getting is kind of like a rectifier here in a way. I can turn the knob easily this way for good, but if I go the other way, it tightens right up. So it's gripping the string more this way, tightening it. Yes, a rectifier of knobs there. So 3 bands on here. Yeah, broadcast, shortwave, and FM. Excuse me. So the FM band goes from just below 90 to just above, well, 106 actually. I think that's 105. There's 106 here. This must be 107. That'd be right? 100, 101, 102, yeah. So it goes up to 107. And probably slightly beyond. Good. Just beautiful. This is in beautiful shape. Really beautiful shape. Oh boy, I'm nervous. You can definitely see the knobs have a bit of dirt on them though. This has been in action. Wow. Well, we should take the back off and look inside. So far, I'm very much inclined to plug it in and see what happens right away. Out you come. A little bit of information here. Tubes. Magic eye tube. And these other things are shown just to help you orient yourself. So it's really about replacing tubes. That's what that's really helpful on. So I'm looking inside here already. And it looks like no one's worked in here. Some very interesting stuff. Hey, I see some very interesting stuff already. This looks quite interesting. A plastic sheet with components mounted on it. It's like an integrated circuit just done on a piece of plastic. That's really odd. That's odd. So this is indicative of the kind of old unreliable capacitors that can be found in a radio like this. These are molded ones here. I see an electrolytic capacitor sitting right there. I'm going to take a wild guess. I won't even take a guess. I think I know what that is, but I see there's another one right here. The flat disc capacitors have been folded flat onto the top here. This fairly high wattage resistor appears to be burned. It's blackened right in there. I don't think it's broken. Power supply, transformer, filter capacitor, fuse. Some of these radios have fuses in the high voltage circuit. I don't think this one does, but it looks just fine. There's the AM antenna. Looks like it has all of its tubes. I don't see any empty sockets. There's a big molded capacitor here that's probably got to go. The whole thing is built on a circuit board. So that's the on-off switch right there. It's a toggle switch. They often fail. So I'm going to flip this radio right over, and we're going to see what kind of access we can get under whoops, sorry about that, under here. Then we got four screws here. This one's in with a rubber washer instead of a metal washer. Somebody been here? Somebody done something? So is this supposed to just slide out? Slide out. Looks like there's a terminal probably connected to the aluminum here. It's probably tied in somehow. There's a staple right here. This piece is stapled right here. It does look like a sliding slot. Looks like it would not make it past here. For some reason they've opened this gap here. Why would they do that? Why would they do that? Some dimensional interference, maybe from that bracket right there. They built this whole radio and then discovered that there's an interference problem right there. See can you see the cabinet is also shaved back right here, slightly. So that may be why the slot is here. I don't know. So should I pop these staples out and slide it off? I think I got a problem with this thing. I think this thing is I like to look up from underneath. No, of course not. So it looks like we get no real advantage through here. This has to come off. This has to come off. So we're on the bottom of the radio here. If I mark it up, it's not really the end of the world. Something a little bit sharper. Now, I have a new tray for putting my parts in. Thank you. Oh, I'm sorry I don't have your name handy. Someone mailed me a little parts tray, magnetic parts tray. I bet it's not in here yet. And I think they sent it quite a while ago. It's been sitting with my son at his house for a few months, and I just got it. Darn it all, I don't know where it is. So I'm going to put this here. I'll find it later and bring it in. Help me never lose little parts like that. Okay, hold on out. Now, my thinking is I can slide it this way a bit and reveal what's going on here. Yeah, it's my thinking. It's not going to slide at all. We'll lift it right up. Make it. I don't think so. It's about a quarter of an inch here. That wouldn't be how they do this. Very stiff. Okay, this doesn't seem to be going anywhere. We're not going to get a look under here. Not now. Not without bringing the chassis out. And I'm certainly not ready to do that. Okay. So we're going to start this guy up just as it is. Now, you know, there's many ways of going about doing radio repair work like this. There's all kinds of approaches you can take. You know, there's like a dozen things or 2 dozen things that need to be done. They can be done in different orders and all that kind of stuff. So one of the things I like to do is get the radio operating as soon as possible, to any degree, because I find it extremely reassuring. So we're going to try it as is. I don't think there's any reason to be too concerned. Part of the reason I'm not concerned is because I can control the current flow going into the radio. So if there's something seriously wrong, the radio will not get damaged. And I hate to sound like a broken record because I have to repeat this on so many videos, but this is the first video in a series, and I know I may have some new viewers. I know I have at least one new viewer. So I will explain very briefly how I prevent radios from catching fire when I first plug them in. I use these two light bulbs here. This one is loose, this one's screwed in. I have a little control panel right here with a couple switches on it. There's a main on-off switch for the control panel. This one's a selector, and this is about directing power to my bench outlet. This is actually the extension cord here. This gray wire is going to this voltmeter, which you can see is saying 0. And this guy, these are cool. I recommend anybody to get something like this power line monitor. You can plug this in your outlet and plug your vacuum cleaner, whatever you want, in here. Then for the first time you can find out how much power it really uses. Lots of fun. Run around the house once with one of these things and your eyes pop open. So I have it here because it's quite handy. This guy can read everything. Frequency of the power line, which is always 60. Watts, volt amps, the whole shot can be on here. Even kilowatt hours. I never noticed that. Kilowatt hours even. It's called kilowatt. I'm not trying to sell this. Don't know if you can even get this still. But there's lots of things like this. So very handy on my bench. So I'm going to plug the radio in. Now, I'm not plugging it into a normal power outlet at all. I'm plugging it into this. This is a transformer which stands between my bench outlet here for project outlet and the Ontario power system. The Ontario power system. So the idea is the power on my bench is no longer referenced to earth, which kind of means you can't get a shock to ground from a project that's plugged into this box. But that is only true under very special circumstances. So I'm not going to try to explain all this because it's really quite complicated. All I would say is if you're working in your own shop doing this kind of stuff, especially if you're working with vintage gear, I have vintage gear all over the place too, which also has issues. You need to know what you're doing. Good luck to you. I say. That's what keeps people safe, is knowing what's going on in their shops. Right? And I have learned the hard way a few times. Okay, enough of that. I don't want to be speechy. I'm not really trying to teach anybody anything, although obviously that happens. I'm really just trying to fix this radio. So we're ready to go. So I'm going to apply the power to it. Make sure it's turned off. It's off. So the power is being applied to it through this light bulb. And we can read 124 volts. And although it's just out of view, this meter's popped up also, showing the voltage at the outlet. Now, when I turn the radio on, it's going to draw some power right through this light bulb. It may be enough to make the light bulb glow a bit. Probably not. I'm going to guess it won't, but it might. The first power that goes into a radio like this is a rush of current into the ice-cold heaters in the tubes. The rush lasts only a moment. The heavy current heats the heaters very quickly, and the whole thing's over in just a fraction of a second or a second or so. From there, the current draw on the radio is low for a while, until the heaters heat up their cathodes. Once the rectifier cathode, if rectifiers don't normally have cathodes, once the rectifier gets hot enough to start doing its job, a rectified B+ will show up on the tube plates, and the tubes will start conducting. That'll draw a little more current, and the radio will be headed towards full operation at that point. The whole thing takes about, well, it varies. Last radio I had took a long time, like about 25 seconds. Most 10 seconds going through this kind of process. The last stage is, of course, you hear the sound come out. So what that means is we can use this light to understand what's going on in the radio a little bit, provided the light comes on enough that we can see it. I'm going to darken down my shop here a little bit. That'll help, because I suspect this radio doesn't draw much power at all, and we'll have a hard time seeing the light. How dark is it going to get in here? Okay, so cameras are coming. That's good enough. I think for this, I think that's good. Give you a good look at that light. So now I'm going to switch off the power, turn on the radio. I'm going to pick a broadcast, make sure the volume's down on it. Probably a light's going to come on here, and this light's probably going to come on. Watch this bulb for that pattern of going up, going down, staying down for a while, and then coming up a little bit. Here we go. There's the first pulse. The heater's heating up. It was way down, so the heaters are not conducting a huge current anymore. Now it should start coming up again. And there's one bright light in this radio. There it comes, coming up again. Now we should start hearing it. Let me turn it up, turn it up. Turn it up. I don't hear anything. I hear nothing. Nothing is heard from the radio. No sound. But quite a bright light. Okay, lights back on in the shop here. So what that tells me is that largely the radio is behaving normally. Nothing really unusual going on in terms of the power it's drawing. Also means leaving it on like this, probably not risky. If something were to happen now, all that would happen is the light would become very, very bright, and whatever happened in the radio would be protected to some degree. So this keeps me from being dependent upon my house safety breaker over in the fuse panel, just in the next room. It's a 15 amp breaker. I have to draw 15 plus amps through it for it to operate. What happens if you have a fault that only draws 10 amps? Well, 10 amps will start a fire, 10 amps won't open the breaker. So that would be the problem. Hello? Hello there. Hey, how do you like that? It's making some noise now. Let's fiddle with the radio, because I'm quite reassured we can do that. I hear a slight hum. That's good too. That gives me some idea of what's going on with the output tube. And that noise we just heard also reassuring. So I'm going to switch bands and listen for crashy sounds. And oh, look at that. That seemed to fix it up there. And these switches are often dirty, and sometimes they won't make any contact. And you can't even, you'd be doing this thinking, well, something else is wrong, because usually you hear, clicks and static sounds when you do these. So with it working, okay, now that's full volume. That's not too impressive. Broadcast. This is the tuner that won't tune. So for some reason, not only is the pointer not moving, nothing's going on in the radio. It's not tuning. Pretty sure. Wait a minute. Let's look in the back here. Maybe it is tuning. I'm trying to get a look at now. Oh my gosh. Well, wow, get close to that antenna. Hey, look at that. My gosh, I fixed it already. What did I do? I tapped the antenna. I don't know. It seemed to like something connected there when I tapped it. Doesn't seem that way now. Sounds more like a radio though. Oh, I still can't tune it. And it just went quiet again. Oh, God. Button. Oh, volume control. Volume control's nice. There, I just, it could be loose tube. Another one back here. And I get a shock here. On here. I say bingo. Wow, it's quiet now. This is the output tube here. Okay, so that may or may not have corrected the tube contact problems that may exist in here. How come it went so quiet? Did I turn it right down? Now that sounds like a radio. Okay, sounds like a cricket, but I still can't tune it, of course. There we go. Hey, we're getting along here. Pretty good already. Shortwave. Now, shortwave would be looking for a wire antenna. I have one right here. Again, I won't be able to tune this. Oops. Oopsie doops. So this was the antenna here. This was the ground. This was the antenna. Leave the ground off. At the moment, my antenna is not actually, I don't think the switch is closed on this, so it's a long lead wire to nowhere. But hey, it's happening. Something loose. Probably those tubes again. And I can't tune anyway. But yeah, it's kind of a waste of a time putting an antenna on there, Jim. So, wiggling some more tubes. More tube wiggling. Wow. Feedback there. Usually a little bit of wiggling and all the crap goes away. We'll leave this off because I can't tune it anyway. But now we're getting ready for the big moment. FM. You know what I got to put? Ooh, what was that? That's me bending over. What? No, I'm just imagining it. Human beings can't stand coincidence. We cannot stand it. We deny coincidence. So the FM is here. I'm just going to hook up to one of them with a piece of wire here. So I just start off with. If I can do it. Can't even do it. I need a little. I need a little plug to get in there. I'm going to stop for a minute and get the antenna sorted out here. Okay, so this is what I've got for an antenna, a pair of rabbit ears, basically. Just gonna stick it. You know what? I should have this hanging from above. I think I have enough wire here to do that. There we are. Okay, so it's hanging up there. Now we're going to find out if the FM works. There's a radio like this with FM makes it way more valuable than not. Volume down, FM on, volume up, way up. Hear a faint power supply hum, no interstation hiss. Okay, volume about halfway. Let's tune it. Reception's a little poor. So the strongest stations are down in this area of the band here. Volume's up full. This really does nothing. No reception. Oh. Hey. Well, it's a gigantic thumbs up, because anything is better than nothing. Now we're running the radio with a reduced supply voltage. It's only running on 100 volts because 20 is disappearing on this light bulb. So despite the fact that this got some kind of a automobile headlight going in here, I'm going to put this up on full voltage, see if this clarifies this FM station a little bit. At this point I am relying on my house breaker, but that's okay. Now, I gotta watch out for copyright issues. I have the feeling we're sitting on a religious station. Not many religious radio stations in
Ontario Christmas Superstation 100.3, the color in park. I like to say park.
Yeah, I heard you singing, I think, earlier.
Really? Yeah, I like this thing. It's Clean Water Christmas here on Life 100.3. It's a special day where we're going to get clean water to kids in Ethiopia. The goal is 1,000 children. Yep. And it would be great if by the end of the Get Up and Go show that we were halfway.
Clean water in Ethiopia. You know, that's a great thing. We have clean water issues in Canada with remote communities. It's a big issue in Canada, a big issue. Yeah, we have like communities of 3,000 people can't drink the water that comes out of their taps. It's a big issue here in Canada.
Physically distanced from us in the boardroom is Executive Director of Health, Hope and Healing International, Ed Epp. Ed, we're so thankful
Same station.
for what people have been doing.
There's another one there. Why so weak down here? Should get strong stations right in here. Be my lousy antenna? I don't think so. It's actually not that lousy. So it is picking them up. Weekly. Okay, so big issues here. Obviously getting the AM and shortwave to tune. The problem is probably a slipping string type problem, but it could be much more serious. It could be the shaft on the tuning capacitor is frozen in its sleeve. There's a chance it's unrepairable. Hopefully that's not the case though. Hopefully you just will work at it and it'll free it up and get it going. So be able to tune, because that's two bands. Generally the radio's functional value is in the FM band. FM seems okay, just weak. Weak can be, oh, who knows, right? Everything from my lousy antenna to weak tube to bad contacts to most likely some bad capacitors in this guy. The next step with them is to extract the chassis. Take a look at underneath. If the radio didn't work at all, I would be really anxious about doing anything with it, because with it not working, as you work away on it, you could be making it worse and worse without realizing it. And when you're all done, you've now got the original problems, whatever they were. Maybe some of them are removed because you've done some capacitors, but you've installed your own problems inside the radio. And I've been there too many times. So thank God it works to some degree. Look at the complex coiling right around the antennas here, just behind the FM tuner. There's the adjustments for alignment. The IF cans are doing both AM shortwave and FM. And so you got two sets in here, probably this way. Two sets this way. There should be another coil in here for adjusting the FM detector. Goodness knows where that is. Usually it's a large can. I don't know. We got to get it out. we got to take it out. The speaker will not come with it. But you see the speaker's transformers up here, and it has a cord. Often these have plugs on them. This one doesn't. So a lot of these radios are designed for the repair person to take the chassis out by rotating it 90 degrees out like this. Maybe this way. So you can leave in the speaker and maybe some other things. The magic eye. Is there a magic eye on this radio? No, there's no magic eye on this radio. Also, I have to get the schematic for it. And what is it called? I can't read that. I don't know what that is. What is that? Norma Luxus. I have no idea. We have Norma Luxus radio. I have no idea what that says. Maybe it's written again back here somewhere. Maybe it's on the back of the radio. There it is. It's that part that they covered. Norma Luxus. Norma Luxus 59. Norma Luxus 59. That's what this radio is. Okay, I'm pretty excited about that part. Let's take the chassis out and we'll take a look at it. And I'll end the video with just the quick turn the power on before I forget. With just the examination of the radio and some notion as to what we have to do to fix it right up. Okay, screws out. Okay, speaker wire. You know what's catching? There's a wire on that piece of cardboard underneath. I think there's a ground wire. Now, you know what? And here it is. I found it. It's right here. Soldered. Soldered to there. Surprising. And normally this would be just screwed onto something. Okay. Let's carry on here. Out she comes. So one of the things we haven't talked about yet is the rectifier in this radio. Like a lot of these radios, they do not have a tube rectifier. They use a solid state rectifier, a fairly substantial guy. You can kind of see him in the background here. It's reasonable to consider replacing that. It's also reasonable to consider leaving it. So the way I'll make that decision is eventually I will test that for how hot it is. If there's a lot of heat building up in it, change it. Modern components are very tiny compared to this very big thing. But if it's not hot at all, there's really no reason to change it, in my view. And there's lots of reasons to not do things. Every time you do something to a radio like this, you take a risk. So what we really want to see now is underneath the board. Actually, I'm getting a little better look at what's up on top here. So again, you can see this resistor definitely looks like it's gotten too hot. It's on a little insulating sleeves here. or physical sleeves to raise the resistor up off the board. You improve its heat, and it's also, look where it's located, right at the back of the radio. It's not up here in the middle, it's at the back, throwing its heat away hopefully. Of course, it's working right next to this strong tube, which is pretty hot. This is probably a heat shield here. I can't imagine it's an electronic shield, a little too small. Probably a heat shield, maybe even just protecting the capacitor there. But you got this thing, this odd. This is a really odd thing. Must be an example of a very early version of something. And like I said, lots of little adjustments up in here for doing the alignment and the like. Way down there. Does anything else look like it's blackened from burning up? I don't think so. Let's go underneath. Flip it over, it would be sitting on this and this. It's really not the best thing. Flip it up on its side, on its end, then it's sitting on all this, plus these. No, that's not so bad. I probably shouldn't have put my finger on those. So I'll flip it up this way. A little more room. Holding it by something solid. You have to kind of keep a little bit vigilant on where the string is. We didn't examine that yet, did we? Yeah, we'll do that next. String and why doesn't it? You got to keep an eye on where the string is so you don't accidentally break it. Well, lots of solder under here. A little bit of corrosion right here. Not much to see under here, really. All looks quite well. Looks fine. This part appears to have been solder dipped, but this part not. Usually when they do these boards in a solder bath, the whole board is soldered that way. These are really large terminals here too. Interesting. Don't know why. There's some element of the manufacturing process that made sense to them or something. I don't know. But not much to see under there. Lots and lots of solder. So everything is up on top. There's no components under here at all. Everything is up on top or on the sides. Look at this little arrangement here. Right, tuning capacitor. Perfect. We're looking right at it right there. So this must be the shaft drive for this tuning. It's probably gear driven in there. And this is the FM tuner up here, and that's the drive and the string for it. So first I'm going to put this down. I'll try turning it by hand with help. Well, that's no problem. That's really no problem. So it's turning, it's just really stiff. It's really, really stiff. So that's just a lubrication issue. That's nothing. Now the question might be, what exactly is stiff? You would tend to think it's this and it's a shaft back in here, and you're probably right. I'm probably right. We're probably all right. But sometimes it can be even this. I don't think so. This doesn't feel. No. Is there anything else in here that could cause that kind of drag? There really isn't. It has to be the capacitor. So let's work on that. Let's work on that. So there's a metal sleeve coming out. It's very hard to see. And the shaft goes in the sleeve through there. The sleeve is often the place where the resistance is developed, mostly just from worn out lubrication. So we want to drop some solvent onto the shaft where it's going into the sleeve. which is easier said than done. The string right here, I really don't want to bung up the string. And I get my favorite elixir here, WD-40. Make an attempt to spray it on the shaft. I can't even see it. I know it's there. I think I can barely see it. Right up in here. There. Nope, nope. I'm spray it all over the sleeve and not get it on the shaft. I can get my finger in there, can I? No, not really. Maybe here. Gotta find some way to direct the hose. Towards the back. Towards the front, actually. How about a stick? Thing about these cans is when you go to spray, the nozzle wanders around too. That's where I want it, right in there. Wow, it went everywhere. Went everywhere, but not on the string. Quickly, now we need to turn this right away. So you can imagine it's a shaft and a sleeve. It takes time for the solvent to go up. What's that? What's doing that? Don't see anything. It can take quite a bit of time. And in really bad cases, you have to heat the shaft up. Too much on it. It's dripping off the bottom here. Can we get on the string? We just have to leave this. It feels quite loose right in this area now. So I think we're going to have to let it... I'm going to have to do something like this for a long time. Come in here and periodically move this. Let's see if it's good enough yet. Still takes a pretty good pressure here. It's moving. I bet you it'll go one way though. It's having trouble that way. Let me help it. Help it across. Bet you it comes back. Yeah, it comes. So it goes one way. So this is the thing. The way the string is wound on the shaft, you turn it one way, nothing out. You turn it the other way, and it actually tightens the string up slightly. It grips onto the shaft. So you get these things going in one direction. So if you're looking at these things at a yard sale or in a second time around store or something like that, you want to do these tests and make observations. This isn't something to scare you away. Eventually, it'll get all the way over to here. And then there's no getting it back. So find a radio like that. It's all indications of just silly little string problems. Feels very tight in here. So now maybe there's another point at which I can spray in the magic elixir here. Hard to see. Let's get the close-up camera going on this. Okay, so we're trying to see the shaft, but the camera is blocking the light, which is often the case. Get a little more light in there. It's all that brownish stuff. Must be like rosin or something. So there now down lower you can see the gears on this guy. Oh, don't fall over, camera. It's not too happy to help me with this. moving. There's the gears down in the lower part of the image. You can see some teeth there. A strange, what is that going across there? Reflection? I don't know what that is. Some ghostly thing traveling back and forth there. Right? Oh, that's the string moving with little frays on the string. Okay. Well, I'm going to go in. I'm going to try to spray on the gear you see turning there in the lower part. And some of that will get on the back side of the shaft that's coming through. And then we will kind of oil the shaft from both sides, kind of, as best we can. WD-40 contains solvent that is very useful for this kind of thing. I'm going to spray down in there. And right there. Wham! Wham! That's it. Occasionally when you're doing this, when you hit the mark, the thing just loosens right up. Feels a little looser. But nowhere near loose enough yet. I think if there were other restrictions in the system, then I'm pulling on the string by turning the big wheel. The spring here would feel tensions, and you'd see the spring expand and contract as I did this, but you don't. So I don't think there's any restrictions other than this shafting spinning here. Now that the shaft is also supported in two other places in these capacitors, often. Most importantly, at the other side of the capacitor, there is a point pivot. Can't imagine that causing too much friction, or so this really isn't loosening up all that much now. Feels the same all this time. I don't think we're going to be able to tune it. Oh, look at that. She's going both directions. So this is bound to get better and better as we go. Not bad. We should play the radio so we can tune in. I think we should do that. Yes, I've got the speaker still connected. We can just play it out here. You see this wheel is jerking around. It's only because my fingers are bumping the other control when I'm doing this. There's no mechanical interlock between these two things. Okay, FM, AM radio check. Okay, put it on broadcast. Volume down. We don't hook up an antenna in this case because it has the stick antenna. I'll plug them back in. Power's off. Again, volume down, switch on to broadcast. Is there anything that I should be panicked about? I don't think so. No need to panic. Power on. There we go. Still using the dim light. It glowed there for a moment, and I think we'll be able to see it again in another moment. Of course, the other strong indication is the headlight that comes on this radio. Okay. Ooh, that just sounds terrible. What was that? That sounds better. Aye. Okay, man. What do you get? So this radio, let's see, broadcast. So the dial runs backwards from North American tastes, if I can put it that way. The low end is here, high end is there. AM stations should be found right in this area. There's one.
On if you think we should be still areas of lockdown. 416-870-6400. Out to the roads for a look at the drive. 640 Toronto.
There's no tone control on this radio.
Are we prohibited to that?
A little busy on the East Gardner collectors through Kipling. We have the ports of a stalled truck on the East Gardner
Yeah.
off-ramp to
So the outside does move.
So just try to stay with the eastbound Gardner Express lane through there. The rest of the Gardner is trouble free, but still a little bit.
It's just really stiff.
Earlier problems northbound on the Allen and Wilson. That stalled truck now clear. Now at Pizza, get unlimited medium 2 topping pizzas for $7.99
That's
each.
680 we're listening to. It's rated 680.
Minimum 2, maximum unlimited. Now at Pizza.
I think that's 610. As the civil defense symbol there, that's rated 640. It could be the radio's angle here is the directional antenna is not working for us. I don't know. This is probably 590, showing up at about 610. I think they're talking about sports. It's very hard to hear in here. Hey, let's try the short wave. I'll put the antenna back on. Which antenna? Let's put the same thing I used for FM. It's a terrible thing to use on shortwave, but why not? So we'll hook them up here. Just one wire. Oh, it's easier this way. So that's some amount of shortwave antenna on here now. Full volume, barely hear it. That can be the sign of a weak antenna. I think that's something in my shop actually broadcasting at that frequency. Not sure about that. A little bit of action down here. Where are we actually? What is this? Shortwave 6 megacycles. 17. You're not going to get anything up there. Now the sun's condition is changing. The Earth's atmosphere is changing a bit. Shortwave reception is going to be improving. Wow. That's hey, look at that. Look at that. Whoops. Where'd it go? What happened? Hey, what happened there? We were listening to it and then we weren't. Yeah, we got a lot of problems with dirty tube sockets from this radio for some reason. Very good. Okay, I think the initial assessment is finished here. This radio, I think, just come on, camera. Tangled up camera. Let's turn the power off before I do something stupid. Basically, I think what I should be doing with this radio is changing out just a few capacitors, which we can see here. You know, this guy I'm sure should go. This guy should probably go. And then there's the molded ones I was pointing to before, and you can't see what I'm talking about. This guy, probably this electrolytic, probably this one too. This is a 4 microfarad. One of these two is going to be involved with FM signal detection. There's a molded one up here. That's a molded style, which is unreliable. This one right up here, this brown guy here. I don't think this would be too tough to do. The capacitors up here are more reliable. These ones are all more reliable. And then there's some disc ones, they're fine. So just a few capacitors should probably make a significant difference in the radio's operation. Now the reason for it being weak seems to be weak all the time. Probably because of a weak tube. Probably one of these tubes is weak. So we'll go through and do the tube testing too. And hopefully we'll dig up a schematic because I know what radio this is. This must be the chassis numbers here. So I think this is actually a pretty easy radio to bring back. I mean, it's not that bad off right away. It's not bad off at all. Working on all 3 bands. Yeah, really. Okay, so that'll be the job tomorrow, is to clear out the deficiencies. Let's put it that way.